In this lesson, we will be able to find the measures of angles inside or outside a circle. I have completed the do now. You are to check your answers with the solutions I have written here. For number 1, I combined like terms. 84 plus 32 is 116. So 2x equals 116. Divide both sides by 2. You will get x equals 58. And for number 2, simplify inside the parentheses first. That gives us 240. 1/2 of 240 is 120, so x is equal to 120. Number 3, if I simplify what's in parentheses first, I will have 2x plus 32. In the next line, I distributed the 1/2 to both terms. That gives me x plus 16. And then I subtracted 16 from both sides, and I added x to both sides. So I will have 164 equals 2x. Solving for x by dividing both sides by 2 will give me x equals 82. And that is my answer for number 3. For number 4, 1/2 of the measure of an angle, I'm going to call it x, plus its supplement, which would be 180 minus the angle, so 180 minus x, is equal to the measure of the angle, which is x. If we combine like terms, we combine the 1/2 minus the x, we will have negative 1/2 x. So it's 180 minus 1/2 x equals x. Add 1/2 x to both sides. We have 180 equals 3/2 x. Multiply both sides by 2. You'll have 360 equals 3x. And then divide both sides by 3. We'll have x equals 120. For example 1, we are going to use the fact that when a chord and a tangent line intersect at a point of tangency, the measure of the angle is half the measure of the intercepted arc. So, in example 1, part A, we want to find measure of angle 1. We know that the intercepted arc right here is 210. We have this chord and this tangent line, and they intersect at this point of tangency. So, the measure of angle 1 is equal to 1/2 the intercepted arc, which is 210. We solve this. The measure of angle 1 equals 105 degrees. We can use the same idea for part B, where we are trying to find the measure of arc RST. Measure of arc RST means that we are trying to find this major arc RST. We know the angle, which is 98, of the chord and the tangent line at the point of tangency, point T. So the interior angle is 98. That angle equals 1/2 the measure of the intercepted arc, measure of arc RST, which is what we are trying to find. So to solve for the measure of the arc RST, we will multiply both sides by 2. Multiply both sides by 2, and we will have the measure of arc RST is equal to 206 degrees. And then we can do part C the same way. Take a moment and try to do that for yourself. Alright, so what we should have is we're trying to find arc XY. When it's just the 2 letters, we're going to be talking about the minor arc XY. So the point of tangency is at point X, and we want to find the measure, the green arc. So we have the angle is 80, so we have 80 equals 1/2 measure of arc XY. Again, just like part B, we're going to solve it the same way. Multiply both sides by 2 to get the measure of arc xy. Measure of arc xy will equal 160 degrees. So, on to example 2. Example 2 will use a new fact. The measure of the angle when two chords or secants intersect inside a circle is equal to half the sum of the intercepted arcs. So in our problem, part A, we will use this fact. We will use this fact. This fact talks about the measure of an angle when two chords or secants intersect inside a circle. The angle that this is talking about is this angle right here and the angle below it. It's only one of these angles. So this angle measure is half the sum of the intercepted arcs. We want to find this intercepted arc, so that means we're going to need this angle measure. We can find this angle measure because we see that line DB is a line, so that means the angle here is 180. So let's go ahead and find that angle. That angle will be 180 minus 102, which will give us 78 degrees. I will put that in my diagram. This angle is equal to 1/2 the sum, which is addition, of my intercepted arcs. My intercepted arcs is y and 95. I need to solve for y now, so I will multiply both sides by 2, and I will have 156 equals y plus 95. Subtract 95 from both sides, I will have y equals 61. So my y is 61 degrees. Now, we will go on to example 2, part B. Example 2, part B uses a new fact. This new fact is right here. You read along. When two secants or tangents intersect on the outside of a circle, the measure of the angle is half the difference of the measure of the intercepted arcs. So it's the only difference now is that the angle is half the difference when it's on the outside. So we know in this problem, part B, this angle that it's talking about is this angle outside, which is 30, is given to us. And the two intercepted arcs are arc KH and arc FG. It looks like we want to find arc FG, which will give us A. To just set this up, the measure of the angle equals 1/2 the difference of the intercepted arcs. When we talk about difference, we want to take the larger arc, so in our case is arc FG, and then subtract the smaller arc from the larger arc. So we will have A minus 44. We solve this, multiply both sides by 2 to get rid of the fraction. We'll have 60 equals A minus 44. You add 44 to both sides and you have A equals 104. Alright, next we're going to move to example 2, part C. Example 2, part C is going to use the same fact that we had when two secants or tangents intersect on the outside of a circle and the measure of the angle is half the difference of the measure of the intercepted arcs. So in part C, we see that in this picture, there are some right triangles given to us. Since there's a right angle here, we know that QT is a tangent and also QR is a tangent because of this right angle. With this right angle and these right triangles, we want to think about finding some measures that we know using trig identities or trig functions or Pythagorean theorem. In this case, we're going to be using trig functions. We're going to need to find this angle Q. So we're actually going to need to find angle TQR. We can find 1/2 of TQR because we know that this larger segment, this segment from S to Q, is 5. And that's because this outer piece, this external segment, is 2, and we know that the radius is 3 because we see that given in our diagram. So using that fact, we can find the angle using a trig function. This is according to this angle TQS. We know the opposite, 3 is the opposite side. So we have opposite side. And that 5 is the hypotenuse of the triangle. So we want the trig function that is opposite over hypotenuse. And that one happens to be sine of the angle. So we're going to call the angle that we want to find alpha. So we put in opposite is 3. The hypotenuse is 5, and that's equal to sine of alpha. To find just the angle, that's going to be inverse sine of 3 over 5. Punch it in our calculator. We will get alpha equals approximately 36.87 degrees. With that angle measure, we know the measure of angle TQS. We want to find the measure of angle TQR so that we will be able to find angle X. TQR is 2 times the measure of angle TQS. So that's equal to 2 times 36.87. So that means our measure will be, as soon as I can calculate it, approximately 73.74 degrees. Knowing that angle, that is equal to, this is equal to half the difference of the intercepted arcs. X is actually talking about the measure of arc RUT. It's not RU, it's RUT. So, to find the measure of arc RUT, we're going to use this fact. When two secants or tangents intersect on the outside of a circle, the measure of the angle is half the difference of the measure of the intercepted arcs. So, let's write an equation for that. The angle is 73.74. That's equal to half the difference of the intercepted arcs. Now, the larger arc is X, which is what we're going to be trying to find, but we don't know exactly arc RT, the minor arc RT. We don't know that. But since these are tangents, they intersect at only 2 points, so that means it's breaking up 360 to get this. So you're going to actually have X minus 360 minus x. And we're doing that because 360 is the total circle, and then we're subtracting x, which is what we're going to be trying to find. If we combine like terms, simplify the inside of these parentheses, we will have 73.74 equals 1/2 2x minus 360. I'm going to continue to solve this for x. You're going to need to multiply both sides by 2. Multiplying both sides by 2, I will get 73.74 times 2, 147.48 equals 2x minus 360. Then we need to get 2x by itself, so we're going to need to add 360 to both sides. And we will have 507.48 equals 2x. Then we're going to need to divide by 2 on both sides to get x alone. So x will be 253.74 degrees, approximately. This may be slightly off, but we rounded, so there might be rounding errors. Now this completes lesson 10.4, and you have your exit ticket to complete for today, 10.5, and your homework for tonight is written right here, page 683, number 3 to 11 on, and number 17, and 32 to 39, that's all of them. That's your homework for tonight, and it will be due tomorrow.